define ground. I just have a battery. I don't define anything. I just have a battery and physically stick a voltmeter probes in here. So yeah, the potential is not defined, but the voltage must be defined. It's just the potential difference.
Probably 0. I would say 0.
You're right, it's 0. So, okay. But it's not that easy. So I'm gonna first do this experiment. Ooh, what the hell? Whoops. Oh. So I'm gonna do this experiment. So I'm just sticking. So now I'm gonna just measure one battery, and it's not. Whoops. And it's 9 volts. Now I'm putting it in the other battery, and it's 0. So how come? There clearly is some. There is this E field, like from a dipole, and as well from here. So there clearly is a voltage between these points. But if only I connect something between them, it all changes. So before I connect the voltmeter, there is the voltage, there is 9 volts. But when I connect the voltmeter, it's just a static voltage. So when I connect the voltmeter, everything changes. And this point, because there's no current flowing through the voltmeter, this point must have the same potential as this point. So actually then, I can say that between here and here there's plus 18 volts, and between here and here it's 0.
Isn't your question like asking what's the potential between 2 points inside the battery?
Inside the battery?
Yeah, so if you have a plus and a minus, and then it was because you've just, when you put these two together, it's like connecting one. Yeah. So it's like asking what's the,
Yeah, so if that's exactly enough. If I connect this with this, I'm going to have effectively plus 18 volts.
Yeah, and then
Battery.
in the middle you're not going to get it because those 2 points are going to be in the...
So you're asking if there's going to be electric fields as well?
No, I'm just saying, isn't it that the same? Like saying, like, you know, if you're plus 18 and minus 18, what's the potential difference at the point in the middle? It's going to be 0.
Yeah, but if I disconnect the voltmeter...
Yeah, but then if you disconnect the voltmeter, then you don't have to... You have two separate...
Yeah. So then it's different.
Yeah.
So there's a static voltage, but there's no current capability in this.
Yeah, but
You just connect
in that same way, there's no current capability within the same battery. So no current flows from Okay.
Actually, that's a bit different. That's because this potential difference is established by a chemical reaction, which Sarah would tell us, or it would be if she was here. And they just can't flow because electric field inside of the battery opposes the motion of the electrons.
But the point is that it doesn't flow.
It doesn't.
So that's...
Yeah, but the potential, so it's different thing. Electrical potential and chemical potential. Electrical potential is the difference in potential. The difference in electrical potential is 9 volts still, but chemical potential 0, because you've got diffusion as well. So you've got inside the battery. I'm not quite sure if it's really like that, but I think it's like there are a lot of plus charges here and minus charges. Alright, something like this, I think. And they would diffuse, so diffusion pushes them in this direction, but the chemical reaction pushes them in this direction. And there's some sort of equilibrium, so that's chemical potential equilibrium. But the voltage is there, because there's an E field inside. Okay, so next trick question. It's not going to be a trick question, really. It's going to be something very easy, but because you're a physicist, you have to do it very quickly. So you're going to have 10 seconds to do this calculation. It's going to be a circuit. You're going to have like a battery, and you're going to have a circuit, and you're going to have an output. It's going to be clear where the output is. And you have to calculate the voltage at the output. You've got 10 seconds. Okay? Everything is clear? No, it's not the right one. No, it's different. So, because there are two. So this is the first one. The first one is going to be a circuit. You're gonna have voltage, and you're going to have to calculate the currents to the two resistors. Okay? There will be two resistors, and you calculate the currents through the resistors.
Yeah, things very clear now.
Okay.
3, 2, 1, 10, 9, 8, 7, 6, 5, 4, 3, 2,
9 ampere.
1, 0. Okay, the answers.
9 ampere.
So there's one current that's 9 ampere through the one. So can I just put it back? Yeah. Just 9 ampere from to this resistor and 9 milliamps to this resistor.
Oh, sorry, I thought it was 2, 1 over.
Yeah.
Wait, could you go back to the last slide? Okay, sorry, I thought you maybe added a K. Just the first one. Okay.
Yeah. So it's the same voltage across the two resistors. So the current is just U over R. So can you see that if this resistor is 10 times bigger than this one, then the current is going to be 10 times smaller than through this resistor. Easy. And okay, so we can physically do this. We have 9-volt battery here. We've got two resistors like these. That's 1K and 1 ohm. There we go.